Electricity. It's all around us, and our lives depend on it. Imagine what the world would be like without electricity. Electricity is important, but it can be dangerous. Respect it, and it is our friend. Misuse it, and it can be deadly. The purpose of this video is to provide workers with a brief understanding about electricity and how to work safely with it and around it. This video will discuss the following: introduction to electricity, electricity and how it works, OSHA requirements, static electricity, the dangers of working around electricity, safety rules, generators, and locking and tagging. Ever since the first discoveries of electricity were made in ancient Greece, people have looked for ways to utilize its power. Today, electricity is an essential part of our everyday life. From heating and cooling to computers to tools and more, electricity makes our world possible. Electricity is so much an integral part of everyday life that many times we tend to overlook its dangers. The purpose of this training video is to explain how electricity works. It will help you understand the hazards and dangers associated with electricity and how you can protect yourself from injury and even death. This video should not be considered a substitute for OSHA's regulations. Your employer should provide additional training as necessary to ensure your safety. To understand electrical safety, it is important that you understand common terms that are associated with electricity. A conductor is an object or material that has very little resistance to the flow of electrical current. Electrical power lines, extension cords, power cords, and water are good conductors. An insulator is an object or material that resists electrical current and is not considered a good conductor of electricity. Plastic, glass, porcelain, and dry wood are insulators. Grounding is when one creates a low resistance path to the earth for electrical current. Grounding prevents buildup of voltages that could cause an electrical accident and is considered a secondary protective measure. Amperes is how an electrical current is measured. Voltage is the pressure that drives or pushes electrical current. A transformer is a device that increases or decreases voltage in an electrical current. Now, let's look at how electricity works. A simple analogy will help explain. Using electricity is like turning on a water faucet. There is a source of water, a way to transport it, and pressure to make it flow. The faucet's water source is a water reservoir or pump station. A pump provides pressure for the water to travel through the pipes. Likewise, with electricity, there is a source, a way to transport it, and pressure to make it flow. The source is a power generating plant. A transformer provides the pressure or voltage for the electrical current to travel through the conductors or electrical wires. The conductors are insulated to keep the current contained and moving to its destination, and to help prevent shock, burns, and fires. Electricity travels in closed circuits, normally through a conductor. Most electrical conductors are made of metal wires and cables that are then wrapped with an insulator. Electricity always attempts to travel to the ground and looks for the shortest path. Electricity will take the path of least resistance to reach the ground. OSHA has mandated certain requirements for use in the construction industry. two types of grounding are required by OSHA. Grounding does not guarantee that you will not get a shock or be injured by electricity, but it does reduce the risk, especially when used in combination with other safety measures. The first ground is called a system or service ground. A system or service ground is designed to protect machines, tools, and insulation against damage. A neutral conductor wire, usually a white or gray wire in low voltage circuits, is grounded at the transformer and at the service entrance to the building. The second ground is an equipment ground. This grounding helps protect a worker should a malfunction cause the tool's metal frame to become energized by providing a second path for the current to pass through from the tool or machine to the ground. OSHA also requires employers to provide either ground fault circuit interrupters, referred to as GFCIs, or a scheduled and recorded Assured Equipment Grounding Conductor program. A ground fault circuit interrupter is a fast-acting circuit breaker designed to shut off electric power in the event of a ground fault within as little as a 40th of a second to prevent electrocution. A ground fault is a break in the low-resistance grounding path from a tool or electrical system where the electrical current may take an alternate path to the ground through the user. A GFCI works by comparing the amount of current going to and returning from equipment along the circuit conductors. When the amount differs by approximately 5 milliamperes, the GFCI interrupts the current, shutting down the equipment. The employer is required to provide approved GFCIs for all 120-volt, single-phase, 15 and 20 ampere receptacle outlets on construction sites that are not a part of the permanent wiring of the building or structure and that are in use by workers. If a receptacle or receptacles are installed as part of the permanent wiring of the building or structure and they are used for temporary electrical power, GFCI protection shall be provided. Receptacles on the ends of extension cords are not part of the permanent wiring, and therefore the cord's receptacle must be of the GFCI type, whether or not the extension cord is plugged into permanent wiring. GFCIs monitor the current to the load for leakage to ground. The GFCI must be tested on a regular basis. Permanently wired devices should be tested monthly, and portable type GFCIs before each use. Ground fault protection, such as GFCIs, is required by OSHA in addition to, not as a substitute for, industry standard general grounding requirements. The Assured Equipment Grounding Conductor program is a written program covering all cord sets, receptacles that are not part of the permanent wiring of the building or structure, and any piece of equipment connected by cord and plug that is available for use or used by workers. A written description of the program must be kept at the job site outlining specific procedures for the equipment inspections, tests, and test schedule, and made available to OSHA and to all affected persons on demand. A competent person must be designated to implement the program and be responsible for its use. A competent person is one who is qualified to identify hazards and authorized to take prompt corrective measures. Cord sets, attachment caps, plugs and receptacles, and any equipment connected by cord and plug must be visually inspected before use each day. Damaged equipment must be removed from use until repaired. OSHA requires 2 tests to be performed on electrical equipment: a continuity test and a terminal connection test. Tests are required before first use, after any repairs, and before placing the equipment back into service. OSHA also requires the tests to be performed after any suspected damage and before returning to use. Additionally, all equipment must be tested every 3 months, whether being used or not. To perform a continuity test, ensure that the equipment grounding conductor is electrically continuous. This test can be performed with a simple continuity tester, such as an ohm meter or a receptacle tester. The terminal connection test ensures that the equipment grounding conductor is connected to its proper terminal. This test can also be performed with a continuity tester. Employees must maintain a written record of the required tests. The written record should include and identify all equipment that passed the tests and the last date it was tested. This record should be made available to all affected persons and OSHA inspectors upon demand. Static electricity can cause a shock, but is generally not as dangerous as an electrical shock. Static electricity can build up on the surface of an object and can discharge to a person, causing a shock. This occurs more frequently in the winter when the air is drier and you touch a doorknob or other metal object and receive a shock. Static electricity can have more serious consequences. Friction can cause a high buildup of static electricity at a specific spot on an object. If discharged when sufficient amounts of flammable or combustible substances are present, an explosion can occur. Grounding or other measures should be taken to prevent static electric buildup. Never refuel a portable gas can in the bed of a pickup. Always place the can on the ground before refueling. Electric shock is one of the most common dangers of working around electricity. Shocks occur when the body becomes part of the electrical current. The current enters the body at one point and leaves at another, seeking the path of least resistance to the ground. Shock can occur when a person contacts both wires of an energized electric circuit, one wire of an energized circuit and the ground, any metal part that becomes energized while the person is also in contact with the ground. Metallic parts of electrical tools and machines can become energized when a break in the insulation of their wiring occurs. A properly installed equipment grounding conductor provides protection from shock for a person touching an energized tool or machine. Electrical shock can result in a slight tingling to severe burns to immediate cardiac arrest. Wet conditions increase the chances of shock and contribute greatly to low voltage electrocutions. Small amounts of impurities, such as salt, solvents, and acid in water, make it highly conductive. Objects that normally are poor conductors of electricity become good conductors when wet. Your skin and wood are good examples. Use extreme caution when working with electricity in wet or damp environments. Should you or a coworker receive a shock or other injury, seek emergency medical attention immediately, even if an injury is not apparent. Burns are another hazard of working around electricity. Burns are the most common injury received from an electrical shock. There are different types of burns that electrical shock can cause. More than one type of burn can occur when a worker is shocked. Electrical burns cause tissue damage and require immediate medical attention. Arc or flash burns are caused by an electrical arc or explosion near a worker. Thermal contact burns occur when someone touches the hot surfaces of overheated electrical conductors, conduits, or other energized equipment, or when clothing catches fire from an electrical arc. When a person receives an electrical shock, sometimes the muscles contract and freeze. This is referred to as involuntary muscle contraction. The muscle contraction causes the person to be unable to pull away from the circuit, causing prolonged exposure to the electricity. Long exposures at low voltages can be just as dangerous as short exposures at higher voltages. Never touch someone if they are in contact or frozen to an electrical circuit. Turn off the power immediately, or use a stick, pole, or board made of dry wood or other non-conducting material to push the person free from the current. Excessive electricity flowing through the body can cause serious damage to internal organs. Internal injuries from electricity may not be immediately apparent and can be deadly. When working at elevations, workers risk a fall. Working with or near electrical lines, equipment, and other energized objects at elevations creates an additional risk factor for a fall. Sometimes when a person receives a shock, the muscles will have involuntary reactions that cause an employee to be thrown away from the electrical current. This often results in a fall that can cause a variety of injuries, including bruises, fractures, and even death. Always use extreme caution when working with energized equipment at elevations, and use appropriate fall protection when required. Other dangerous situations can occur as the result of electrical accidents. These include fires or explosions in atmospheres containing flammable gases, vapors, or combustible dusts. Equipment and machinery can also explode, sending fragmented metal in all directions. Prior to working, and especially digging, contact all utilities for buried line locations. Watch for overhead lines and buried power line indicators. Observe all posted warning signs. Unqualified employees and mechanical equipment should remain at least 10 feet away from overhead lines. And always assume lines are energized. Use ground fault circuit interrupters or have an assured equipment grounding conductor program as required by OSHA. Test GFCIs according to manufacturer's guidelines. Use double insulated tools and equipment. Visually inspect all cords, equipment, and tools before use. Ground all power supply systems, electrical circuits, and electrical equipment. Frequently inspect electrical systems to ensure ground is continuous. Never remove ground prongs from plugs, plug-connected equipment, or extension cords. Ground all exposed metal parts of equipment. Always use tools, equipment, and materials correctly. Never use multi-receptacle boxes designed to be mounted by fitting them with a power cord and placing them on the floor. Do not fabricate extension cords out of Romex wire. Never use equipment outdoors that is labeled for indoor use only. Do not use 2-prong adapter plugs on 3-prong cords and tools. Always use circuit breakers or fuses correctly. Never use a larger breaker or fuse than required. Before use, inspect cords or tools for worn insulation or exposed wires. Never remove ground prongs, faceplates, or insulation from wires. Normal wear and tear on extension and flexible cords at the worksite can loosen or expose wires, creating hazardous conditions. Only use factory-assembled cord sets, properly rated, that are 3-wire type and made for hard or extra hard usage. Use only cords, connection devices, and fittings that are equipped with strain relief. When unplugging cords, pull on the plug, not on the cords. Continually audit and inspect cords on site. Remove unsafe cords immediately. Portable generators can also be very dangerous if used incorrectly. Always follow manufacturer's safety rules and guidelines. Read the instruction manual prior to use. Inspect generators before each use. Do not use generators if they are wet or it is raining or snowing. Use only undamaged heavy-duty cords that are grounded as required. Use GFCIs according to manufacturer's guidelines. Shut down and let it cool down before refueling. Never use a generator indoors. Your employer must provide you with appropriate PPE. Always wear the required PPE for the job. Maintain and inspect it. Never use damaged PPE that could compromise your safety. PPE that is required around electricity may include lineman's gloves worn over leather gloves, hoods, arc flash suits, matting, blankets, line hose, and industrial protective helmets designed to reduce electric shock. The proper use of lockout-tagout procedures protects you from the accidental or unexpected startup of electrical equipment or machines. Lockout-tagout procedures are very specific and are beyond the scope of this training video. Your company will instruct you on the need for and correct procedures of lockout-tagout. Electricity is a mainstay of the construction industry. Respect it, and you can rely on it. Don't take shortcuts around electricity. If you don't understand, don't continue to do the work. Stop and ask your supervisor. Be safe and smart. It's the only way to work.